Hello, today we're going to be covering section 9.2 on surface area of pyramids. We will also be covering section 9.5, which is on volume of pyramids. Our essential question for today is only going to be addressing surface area. So our essential question is, how can you find the surface area of a pyramid? Similar to a prism or a box, the surface area of a pyramid is the sum of the areas of all of the faces. Now the difference for a pyramid is that we only have 5 faces. We have the base or the bottom, and then we have the walls that are going to go around the outside of your pyramid. Of course, if your base is a different shape, for example, in the diagram here, we have a rectangular base or a square base. If we had a triangular base, you would have fewer faces or fewer walls going upwards, creating your pyramid. But in the example that's shown, there are 5 faces. I'm going to show a brief illustration of the unfolding of a pyramid so that we can better identify where all of these faces are coming from. Here we have a prism. This is a box where the bases are the same. They are parallel and congruent. We talked about taking the top or the bottom and sliding it all the way down through our figure. We are looking at a pyramid, though. This is an example of a pyramid. If I take this pyramid and I unfold it, the net, or the two-dimensional form, is going to look like this. This square is the base, and all of these triangles fold up to create the walls of your pyramid. Watch as they fold back up, forming your pyramid. Another example is this triangular pyramid. To find the surface area of a pyramid then, I need to find the surface area of the base. So in this case, that base is the red square on the bottom, along with the area of the lateral faces, which are the 4 walls, in this case, of my pyramid. Now, as we saw a moment ago, there might be less than 4 walls, depending on if your base is a square or a triangle or a different shape. In example 1, I am going to practice finding the surface area of the regular pyramid. So what I'm going to find first is the area of the base. Then second, I'm going to find the area of the lateral faces. They are all the same. So I'll start by finding the area of 1, and then I'll multiply it by however many I have. My base in this case is a square with a side length of 5. Since my figure is a square, I multiply 5 times 5 to determine the area of that base. And I find that the area of the base is 25 square inches. So far, I've determined the area of the bottom. But now I need the area of each of the triangles making up the lateral faces of my pyramid. To find the area of those, I notice that the shape is a triangle, and the area of a triangle is 1/2 times the base and the height of the triangle. Base and height always meet at a 90-degree angle, so I see the 90-degree angle of the triangle here. And the height of my triangle then is 8 inches. The base of my triangle, since my base is a square, this side length is 5 inches, so the base of my triangle is also 5 inches. Simplifying, when I multiply 8 inches times 5 inches, I get 40 square inches, and half of 40 is 20 square inches. So what I have found is the area of 1 of my lateral faces. Now I have 4 of them, 1 for each side of the square that is my base. So I have 1 triangle along this side, 1 along the front, 1 going up along the left, and 1 going up along the right. So my entire surface area is going to consist of the area of my base, which is 25 square inches, plus the area of each of my lateral faces. 1 of them is 20 square inches, but I have 4 of them, so I'm going to add on this 20 square inches 4 times. When I do that, I have 45 square inches plus 40 square inches plus 20 square inches, which simplifies all the way down to 105 square inches. So if we are going to cover the entire surface of this pyramid, we find that it will take 105 square inches of material. In example 2, I'm going to again find the surface area by starting with the base of my figure and then adding up all of the areas of the lateral faces. In this case, the base of my pyramid is a triangle, which has a formula of 1/2 base and height of that triangle. The base and the height of the triangle meet at this 90-degree angle. So that tells me that the base of the triangle is going to be this length of 10, and the height of this triangle is going to be this length of 8.7. So my base is 10 meters and my height is 8.7 meters. Multiplying, I find that the area is 1/2. 10 times 8.7 is 87. Meters times meters gives me square meters. And 1/2 of 87 multiplies to give me 43.5 square meters. That is the area of the base or the bottom of this pyramid. Now I need the area of the lateral faces or the walls of this pyramid. So what I'm going to be looking at now are the triangles going up along the sides. Again, that shape is a triangle, so my area is 1/2 times the base of the triangle times the height of the triangle. This side length we can assume is going to be the same as the side length of the other side, which is 10 meters. So that base side length is 10 meters. And the height is going to be this distance, which is perpendicular. It is 14 meters. Multiplying, I have 1/2 of 140 square meters, which simplifies down to 70 square meters. Now to determine the total surface area of this figure, I need to add the base with all of the lateral faces. There's only one triangle forming my base, and that is 43.5 square meters. Then around that base, I have 3 triangles forming the walls, so 3 lateral faces, which means I need to add on that 70 square meters 3 times. Adding all these together, I have 113.5 square meters plus 140 square meters. When I add these two together, I find that my total surface area is 153.5 square meters. The next concept that we're going to be covering is simply the volume of a pyramid. Now, if we are going to, instead of covering the outside of our pyramid with material, let's say we want to fill in the entire inside. So now I want to stack a bunch of cubes or a bunch of dice inside so that we fill up the entire inside of that pyramid. What I'm going to do is use our formula for the area of a pyramid. It's very similar to the volume of a prism, except that now, since our figure is not a prism, instead it comes to a point at the top, we are going to multiply by 1/3 times the area of the base times the height of the pyramid. So in example 1, our formula, the volume of a pyramid is equal to 1/3 times the area of the base times the height of the pyramid. Again, it's very similar to a prism. The only difference is that we have that factor of 1/3 because our figure comes to a point at the top. The shape of the base in this case, it has 1, 2, 3, 4, 5, 6 sides, which tells me that this base is a hexagon. Now we've already been told the area of the base, so we don't need to find that on our own. It is 48 square millimeters. And the height goes from the point straight down making a 90-degree angle with the bottom. I see that that is 9 millimeters. So our volume is just 1/3 of the area of that base multiplied by the height. 1/3 times 48 is 16 square millimeters. And then I still need to multiply by 9. So what I did here in my first step is I multiplied 1/3 with 48. Now my second step is to multiply 16 times 9. When I multiply 16 and 9 together, I get 144. Now square millimeters times millimeters gives me millimeters to the third power, or cubic millimeters. So it will take you 144 cubes that are all a millimeter big to fill in this pyramid. Example 2. Find the volume of the pyramid. Our formula, since our figure has a base where all the sides come up to a single point, this shape is a pyramid, which tells us our formula is 1/3 times the area of the base times the height. In this case, the shape of my base is a rectangle. They tell us the side lengths are 3 and 4. They're different from one another, which tells me that that shape is a rectangle. And the area of that rectangle is going to be 3 feet times 4 feet, which is a total of 12 square feet. The height from the peak directly down to the base is 7 feet. So my volume is 1/3 times the area of the base, which is 12 square feet, times the height, which is 7 feet. 1/3 times 12 is going to simplify to 4 square feet. I still need to multiply by that 7 feet. 4 times 7 is 28. Feet squared times feet simplifies to give me cubic feet. So it will take 28 feet that are all in the shape of a cube to fill in the interior of this pyramid. Go ahead and take a moment to pause the video and try on your own number 1 on your own. To check our answer, the formula for the volume of a pyramid is 1/3 area of the base times the height. In this case, the area of my base is a pentagon. They tell us the area of the base, though, is 21 square feet, so we don't need to find that on our own. The height from the peak directly down to the ground is 6 feet. So my volume is 1/3 times 21 square feet times 6 feet. I will multiply 1/3 and 21 together first to get 7 square feet times 6 feet for a total of 42 cubic feet. So the volume of this pyramid is 42 cubic feet. That brings us to the end of our video today covering volume and surface area of pyramids. Thanks so much for watching and have a great rest of your day.